And in just a second, I'm going to ask everybody for their questions. Okay, it is 9 o'clock on my screen. What are your homework questions? And this was 3/8, the tangent function. So try not to chat because it's hard for me to keep looking down to see if anybody's chatting. Try and open up your mics if you have a question. I see you raised a hand. Go ahead, Isabella. What do you got? Ms. Torres.
Oh, how do you do the periods when it's like theta over a number?
Can you give me an exact problem that we can work on?
Number 5.
Okay. Let me make sure I've got the number 5. This one? Okay. So, oh, I gotta hook up my little machine. Okay, so remember, if this one says, what is the period? We know that for a tangent function, the period equals the absolute value of pi over b. And so we're using the pi over 4, not the theta. So we set that equal to pi over 4. And so what is b? I don't think I'm answering the question they want. They want to know what the period is. Sorry, I'm getting all kinds of people still entering the room right now. Let's see. So there's 21 of you. I'll take attendance in just a bit. Okay, so B is obviously 4 because B has to be 4, but that's not the answer to the period. The period is pi quarters.
I thought B was pi over 4.
No, so, oh, I'm sorry. You're saying this is B, right? Huh.
Yeah.
Hold tight. Let me check real quick, see what's going on with this, because I thought I did this right, but perhaps I did not. Lesson plans. Precalc in progress. 3/8. Worksheet A. Key. Oh, I see what you're saying. You're right. So B is pi over 4, so the period is 4. Okay, sorry. My bad, Bailey. Hang on. I mean, who asked that? Issa, right? Okay, hold tight. Share desktop. You are so correct. So you're right. So B is pi over 4, correctamundo. This part is B because that's in the equation. So if B is pi over 4, we have to say pi over 4, and then we have to simplify that. And that's a keep, change, flip, right? Keep the top, change to multiplication, flip the bottom. So the pi's cancel. So the period is 4. I need to fix my key. I wonder if I did the other ones wrong. Whew. My whole answer key is wrong. Let me let Joey in. Go ahead, Sadie. What you got?
Can you go over 13?
Yeah, and I see you put me a meeting chat. So the period would be n over 4. Where's n? Are you saying
Oh,
n?
pi.
Okay.
Yeah.
And you want me to go over 14?
13.
13?
Yeah.
13, okay. Alrighty then. Okay, so what is the period just from this graph?
I think it's like 1/2.
1/2 pi, right?
Uh,
Because what I'm looking at is,
it may be pi halves.
yeah.
Yeah.
So if you go from this 0 to this 0, those two repeat. So that goes from 0 to pi halves. So we know the period is pi halves. Okay, good. Which should equal pi over b, correct? That's what I got mixed up last time. So what would b have to equal?
2?
Yep.
Okay.
So b equals 2. So this is 1/2. That doesn't work. And this is 4. That doesn't work. There's 2. That doesn't work either. So the period is, well, b is 2. So C is the correct answer. And there's no phase shift because if you remember from the original, let me see if I can go back to it quickly. What slide am I on? 19. You remember from the original graph, this is the tangent function with this inflection point at the origin. So if you have an inflection point at the origin, then you don't have a phase shift. And so we have it at the origin, so we don't have a phase shift. There's the other Alex M. All right. Everybody good? Hey, Alex. All right. So let's see. I found 14 and 15. I found these to be the most difficult. Were you guys okay with all those? Nobody had any issues with those? No, not those. Those are just backwards thinking. Let's see. That's just knowing your unit circle. What was the ones that I found difficult? None of those. Oh, the asymptote one, 6, 7, 8, 9. Were you guys cool with the asymptote questions? 6, 7, 8, and 9? Yeah? No? What would... Okay, there was a lot of people. Was that Cassie? Who just spoke? Cassie, you got your hand raised?
Could you just go over one of them?
Yes, I will be delighted to. Okay, so let me just start with 6. So there's a lot going on here. So what they say is this. Let's go back to our y equals tangent of theta. We know that that has asymptotes, and I know this is really just obvious. At theta is pi halves, and then it repeats every pi k units. Remember, it repeats a period of pi. So the first asymptote was at pi halves in the positive quadrant, and then every pi units later, we get another asymptote. Okay, so what they're saying now is y equals tangent of 2 theta has, change that to a has, asymptotes at 2 theta equals pi halves plus pi k. And then they want to know what the theta is, so we have to divide both sides by 2. If I divide this side by 2, I'm dividing this side by 2. Make sense? So now this theta is now pi halves over 2 is pi quarters. And the new period is pi halves k. That's all you do is you take that 2 and divide it by the original. So the original was pi halves plus pi k. So that 2 divides that and you get pi fourths plus. So I think it's, yeah, it's this one right here. Pi fourths plus pi halves k. Now, what are you going to do with this one to both sides? Since we divided by 2, what are we going to do here? Thoughts? Go ahead, Isabella.
Oh, I was just wondering, for the number 6,
Yeah.
so is that original one, like the pi over 2 plus pi k? Do we use that for like all of 6, 7, 8, and 9?
Yes. That is how we
Oh,
do.
okay.
Yeah.
So wait, where did that come from?
So it comes from the original function. If we go back, why isn't it letting me do this? If we go back to the original function, we see that the first positive asymptote was at pi halves, and the next was at 3 pi halves. So it's a full pi units later. So the generic for a theta angle that hasn't changed, there's no shifting, there's no anything going on, is you start at pi halves and you go forward or backwards pi units. So then in ours, we have to take that, drink all your faces because I can't see what I'm doing here. We have to take that original pi halves plus pi k and divide it by whatever the number is in front of theta. So we take the original equation and we say, now we've got a 2 theta, so we have to divide both sides by 2. So 1/2 divided by 2 is 1/4, and pi divided by 2 is pi halves. And so just real quickly on this one, we're going to say the tangent of 1/4 theta, we're going to say the asymptote was at, we'll say 1/4 theta equals pi halves plus pi k, the original, but now we have to multiply both sides by 2. So what I want to do is say, let's say times 4 here and times 4 here. So you can see the 4's cancel, and we go back to theta, because what we're looking for is the theta angle. And 1/2 times 4 is 2, and pi k times 4 is 4 pi k. And you can see that's here. So if I were to guide you simply, I would say take whatever's in front of the theta and divide it on both sides. Because you could really say we divided by 1/4. If you divide by 1/4, you're multiplying by 4. Divide by 2, divide by 1/4, and you'll solve for it. How do we feel? Okay, Lucas, you guys are raising your hands. Can you, the raising hands thing is tough for me because I can't find where the hands raised are. So can you just like open your mics and say something? I know you think it's rude, but it's not. I'd rather hear your voices than see the hands raised.
Can you do 9 because it's different than 6, 7, and 8?
I can, but what did Lucas raise his hand for? I'm trying to get to that.
I'm not sure.
Lucas!
I was going to answer what you needed to do for 7. Because
Oh,
earlier you said, what are you going to do for 7? And
okay. Are you cool with what I did though?
Yeah.
Okay. And now Isabel's asking for 9. Okay. So 9, haha, it's kind of the same thing. We're just taking this theta minus pi halves and setting it equal to what we know the original was, which was pi halves plus pi k. Remember? The original was pi halves plus pi k. So you take your new numbers and you set them equal to pi halves plus pi k, but we need to solve for theta. So what am I going to have to do to both sides now? Am I multiplying or dividing? Anybody can say?
Adding?
You are adding. We are going to add pi halves here to make this go away. And then we're going to add pi halves here. And I'm guessing you only have to do it once. That is true. You only have to do it once. We don't have to do it here because that would be double counting it. So whatever you do to one side, you do to the other side exact. So now you've got theta equals, well, 1/2 plus 1/2 is 1. And so isn't a pi plus a pi k just one more pi k? So can't we just say, if that's a period, we can get rid of it and just say that's pi k?
Why do you get rid of that pi?
Because it's a new period. So pi times an integer k, that's a 1, right? So isn't that just adding a 1 to whatever k is?
Why wouldn't it be 2 pi k?
Because you don't have a 2 pi k here for one, and because why would you have 2 pi k when you could have pi k? So 1 pi plus 1 pi k is still going to be a pi k number, isn't it? This is an integer number. You guys remember when we were doing periods and we said the period is 2 plus 8 times an integer? Well, all of the 8s go away. So the 2 is left. Well, this is a period, so the pi k is left. Go ahead. Stop raising your hands. Just say something with them.
Oh, for number 8,
Wait, I want to make sure everybody understands this. I feel like there was some. So this was the old way of doing the periods. And we said, whatever the repeat is, we get rid of it. Well, we're not getting rid of the repeat because the repeat is kind of the answer, but you have to have a fixed point. So if I started at pi and moved every pi k forward, isn't that like starting at 1 pi, moving to 2 pi, moving to 3 pi, moving to 4 pi?
Yeah.
Okay.
I put D originally because I thought you had to add to like both.
No, because that's double counting the pi halves. You're putting pi halves on this side, but you're putting pi on the other side if you add it twice. So the dividing you do to both sides. The adding you also do to both sides, but you don't double add. So it's literally just this one. He really likes the answer C. If I look, 6, 7, 8, and 9 were all C. So was, oh my God, where's 10? So was 10. 6, 7, 8, 9, and 10 were all C. And then he picks up on the other side, 14 through 17 were also all C. Did you guys get C for 14 through 17 as well? This guy really loves the answer C. Okay, somebody asked me about which number, 8?
yeah, I was asking about 8, but you kind of answered my question when you said they were all C. Because I don't know,
Yeah.
I was just suspicious of all the C's.
Me too.
But also, for number 10 and 11, how do we find the asymptote?
Okay, so for 10, make sure I'm sending you in the right place. So remember, so you're not finding the asymptote. I mean, the asymptotes are on the graph for you, right? They're at -3/4, -1/4, +1/4, +3/4. This question is what are A and B, and that's not asymptotes. So what is your real question on?
Sorry, I didn't mean to say asymptote. I meant to say amplitude.
Okay, so here's what they did first. They said, let's go find the period first. What is the period just by looking at the graph?
Is it 1/2?
1/2 pi.
Yep, it's 1/2, because if you go from a -1/4 to a +1/4, or from a 1/4 to a 3/4, your period is pi halves. And that's important because we know that that is pi over b. So what is b?
2.
2, which is greater than 1. Okay, and then notice what's happening here. We don't know the amplitude. We only know what sign it has. Do you remember? You were the one, Isabella, when we said what happens when you do this instead of this? What happens to A?
And then it's a negative.
A is negative. We know it's negative, but we don't know exactly what the number is. We just know it's negative, so it has to be less than 0. So we know B is greater than 1. It can't be this one. It could be this one. It could be this one. It can't be this one. And we know A is negative. That can't be right. That can't be right. This could be right. That, oh yeah, this could be right as well.
So, like, the disco arms have to be going, like, towards the positive. Like, they
Yeah.
have to be going above the x-axis when
Right,
it's
they have to
going.
be increasing instead
Okay.
of decreasing. For a tangent graph that's decreasing along its entire length, you have a negative amplitude. And there is a way to find the amplitude, but it involves finding where the 1 value is and figuring out what that angle is, and it's kind of a hassle. But this one was just strictly asking, do you know that this was an x-axis reflection? And I think you do, right? You know that the disco arms are doing not this, but this. So when the disco arms switch, that's a negative A.
So for 11, it's got positive disco arms. Right?
Let's see. Positive disco arms. So A is greater than 0.
Yeah.
Not here. Not here. So we already know it's between A and B. And 11 was not one of the ones that was C. And now B, we have to say the period is, it looks like I'm going I just go from asymptote to asymptote. So from a negative to a positive pi is a period of what?
2 pi.
2 pi, and that has to equal pi over b. And so I just switched the diagonals. Remember, I always just say we can move these two. So I can say b is pi over 2 pi. Well, of course, the pi's cancel. So b is 1/2. So that's less than 1. Disco arms greater than 0, b less than 1. Are you okay with that? I don't think in any of the questions I saw, they literally asked for the amplitude. Maybe on one question in the notes they did, but I don't think they actually say what is the amplitude, do they? Because for tangent, it's not as easy because you don't have a maximum to go to. Yeah, I'm looking, I don't see any question that says find the amplitude. I don't think we have enough right now to find the amplitude. I think what we have is just a general sense of its sign. That's it. Is it really 9:24? My goodness. Okay, guys.
Wait, I have one more question.
Okay, but I see 9 chats, and I told you guys I cannot continue to monitor chat.
How do we do 28 on the very last page? I think maybe I just drew my unit circle wrong.
You said number 8?
28.
28?
I think I might have just done it wrong. My unit circle, because I don't have a 7 pi thirds.
Well, nobody has a 7 pi thirds, so you have to start a new circle, right?
Oh,
So again, if you said, okay, 7/3 is like 6/3 plus 1/3, isn't it? And isn't 6/3 just 2 pi? So you've already gone the entire circle plus another pi thirds more. And you're right back to pi thirds. So if you can take out numbers that are 2 pi units for any of them, really, you're right back to a brand new unit circle with only pi thirds beginning.
also it was like those things where we would make the periods but this is just on a circle.
It's kind of like that. Yeah, if the period is 2 pi, which is not for a tangent, it's pi, you are now all the way back to a start of a new circle. So the 7 pi thirds or 7/3 is really 6/3 plus 1/3. And the 6/3 is a full circle. That's 2 pi. So you should be able to go from there because at pi thirds, isn't it 1/2 √3/2? And isn't the tangent the y over the x?
So would this one just be √3?
Yeah, it is.
Okay.
All right. I don't know. Are you guys just chatting to yourselves? Because I told you to stop. Okay, I got you. Joey said 7 pi thirds is the same as pi thirds. Well done. And Lewis said, it's okay. We're talking to ourselves. Okay. Is 11b? Yes, Lewis, it was. Honestly, I would what? You won't believe me when I say 10 is C. I got B and D for 10. Yeah, no. And what is we less than 3 Brian Passwater? Is that you like him?
It's like a heart.
Okay, so you do like, okay, good. Thank you. I just wanted to make sure nobody was mad at Brian Passwater. I couldn't do this without him, so nobody diss Brian Passwater. Especially
May I ask another question?
go ahead.
It's like I still don't really understand like 2, 3, and 4 and 5 on the first page for the periods. I don't know. I'm just confused. I'm sorry.
Okay, the period. So this is the B value, right? And the period is always pi over B. It's that simple. So pi over 4. This is the B value. So the period is pi over B, and B is 1/3. It's just fraction math. You're just dividing by, you pull the x or the theta out, and then you just divide by whatever's left that's being multiplied, not the shift part. The shift part you have to leave alone. So what if I said tangent of 6 theta? What would the period be?
Would it be 1/6?
Yep, pi 6, right. You have to have the pi in there.
Oh, pi 6.
Yeah.
Okay.
Yeah.
How do we do number 4?
Oh my gosh, you're asking me for the entire thing. What is
Just
the
the
period?
first page.
Okay. The period is pi over B. Remember, I said ignore the x or the theta, but that's B. So
Oh,
it's pi over
okay.
pi.
That's 1.
That's fine. Mhm. Okay.
Okay.
Enough of this chicanery. That's not really the word I was looking for, but it seems to fit. All right, so I am going to unlock the quiz. It's a 3/8 quiz. I'm just going to show you what it looks like. If I can go to Jennifer's. Okay, it's drop down, and there are only, oh God, 24 questions. I forgot about that last page. I was thinking it was only 8 questions, 9. You know what? I'm going to assign this as homework. Don't anybody work on it now. I will see you working on it if you're in there. Do not work on it. Did I even unlock it yet?
Thank you.
Okay, don't work on it. I'm going to see if you're working on it, so don't work on it because I need to teach this lesson and we only have half an hour left.
You're the goat, Miss Amber.
What'd you say?
You're the goat, Miss Yanarella.
Well, thank you, I think. I'm not sure. Okay, did you guys all have your topic 3.9 notes? Please say you found them because I left them with you last class. Everybody got them? Okay, I'm going to take that silence as a yes. Somebody's still chatting. Okay, this is actually not a hard lesson. The problem is going to come that I didn't do it in the right order. I should have done 310 first, but for your basic arcsin function. So when we talk about inverses, you remember that the inverse function is when you switch y with x. So if I said f of 2 equals 18, what is f of 18? You better not be chatting me.
Is it 2?
Yes. If we're doing inverse, okay, so the inverse is you switch the y's with the x. Well, this concept is very similar for sines, cosines, tangents, for trig functions. So we know the sine of pi 6 is 1/2. So I could say inverse sine, and I do not say sine to the -1. I say inverse sine of 1/2 is pi 6. Or we can say arcsine. And they seem to think that arcsin is the preferred way of saying it, but then all of Brian Passwater's has inverse signs with the -1 here. So we could say the arcsine of 1/2 is pi 6. So far, so good?
Yes.
Okay, because the notes are halfway done. Okay, I don't know if you guys can see this, but if I were you, I would highlight it. This piece is the piece we're going to use to restrict the domain. And the reason we do that, and the videos explain much better than I will, is if you have a repeating, so here we go from negative to +1, and now we're going to start going back over all the same values on the y-axis. And for it to stay a function, you can't repeat x values. So when you flip them, you'd be repeating the y values. So see right here, from -pi-halves to +pi-halves, they are restricting the sign so that we only have the values negative to +1 between these numbers and no others. We're going to ignore this piece and this piece of the graph and only focus on this piece. Okay? So notice what they're saying is bracket -pi-halves, comma pi-halves. That is what we want to look at when I say, what is the inverse sign? Don't give me any numbers beyond -1/2 or +1/2. That's all they're saying is restrict your domain. Are you cool with that? I'm not getting any.
Why do you restrict it?
Because, like I said, the guy in the video does a great job of explaining it. But basically what he does, he shows you how the inverse graph is no longer a function, because if you draw a vertical line, the x's will repeat. And he says we can't have x's repeat because now we don't have a function anymore. So in order to preserve it as a function, you can only have the values from -1/2 to +1/2, because then the y's are what's going to repeat. But remember, we're flipping them, and the y's will be the new function for x, and we don't want the y's to repeat. Because see how the y's repeat? Up, down, negative, +1, negative, +1. Watch the video.
Yes.
It's much better in the video. He does a great job, and I can't recreate that graph because it's very complex, but he does a great job of saying it. So now same thing for cosine, only this time they decided to go from here to here, and we're ignoring all of this. So we're only using from 0 to pi for cosine. So notice it goes from 0 to pi. Bracket, bracket. But now, what do you guys remember about -pi-halves and +pi-halves on a tangent graph?
It's a vertical asymptote.
Indeed it is. So on the regular tangent graph, nope, that's not it. On the regular tangent graph, the negative pi halves and the positive pi halves, and then every pi units forward or backward from those are the vertical asymptotes. So that's why we can't say we have one at negative pi halves or pi halves. We can only go up to that boundary, and that's why these are parentheses because of those vertical asymptotes. So notice they're brackets for cosine and they're brackets for sine. Got it? Hello? Do we have it?
Yes.
Okay. So here's what they've got. I love this graphic because the sine is from negative 1/2 pi to positive 1/2 pi. Remember, negative swings this way and positive swings this way. And the cosine is from 0 all the way to pi. 0 to pi. And the tangent, because you can't include the negative pi halves and the pi halves, starts at some boundary just beyond those and goes up to this. So now what they're saying is evaluate the following expressions. Let me see. I made a lot of screenshots today, and maybe, just maybe, I made that one. Oh, that's all my people. That's all my people. Oh, here's a really good one, Sadie. All right. This is what I want right here. So what he did very kindly for us, because he didn't have to do it, is he gave us the pieces of the unit circle we need. Okay, and nothing else. Do you notice that quadrant 4 is not in there? You guys see how quadrant 4 is empty?
Yeah.
Because only tangent and sine go on these two quadrants and only cosine goes here. So nothing goes here. Okay, so when I ask you for the cosine, the inverse cosine or the arc cosine of negative root 2 over 2, you have to look at what? The x or the y's for cosine?
X's.
X's. So where do you see an x of negative root 2 over 2 that is between the cosine's restriction of 0 to pi? Don't go down here for cosine.
3 pi over 4.
Correct. Except it's negative root 2 over 2. Yeah, that's right. Correct. So it is, hello, where are my notes? It is 3 pi over 4. You are correct. Come on. So remember, for the arc cosine or the inverse cosine, we're actually looking for the angle, not the value. Ah, somebody's chatting. Can you guys please stop? I don't know what you said. I don't remember what you said, Joey. I mean, how do I know? You didn't phone in. Okay. So where is the arcsin? A negative root 3 over 2. Now that's the y values, but make sure you're in these two quadrants. Where's the arcsin? Negative root 3 over 2.
Negative pi thirds.
Negative pi thirds, yeah. And where is the arctangent or the inverse tangent? Root 3. Now remember, that's the y over the x. So you're looking for a root 3 in the y and a 1 in the x.
Is it pi thirds?
It is indeed pi thirds. Very good. Okay. Moving along.
Wait, I have a question for the example 2C.
Go ahead.
If this is inverse of the tangent, wouldn't
It
you
is.
do the x over the y instead of the y over
No.
the x here?
No, the
No.
inverse tangent is always y over x. It's always the slope, the rise over the run.
Oh, okay.
So the y value at pi thirds is root 3 over 2, and the x is 1 over 2, and you can see the 2's are going to cancel. Root 3 over 2 over 1 over 2, which is root 3 over 1.
Okay.
All right, moving on. They're giving you these points, P, Q, R, and S, and we don't know anything. We know it's a unit circle, but we have no idea what that angle is. It looks like pi quarters, but it may not necessarily be. Okay, so what they're saying is this. Where is the inverse cosine a positive x value? At which of these 4 points would I call the inverse cosine a positive?
It will not be R.
Yes, it is not R. Tell me why.
Because there's nothing in that column. Or
Right.
that quadrant, I mean.
It is not in the domain. We have to restrict the domain, so R can never be an answer. I love that you saw that. So where is it?
Is it P?
It is. Joey, what are you doing? It's making that metallic clicking sound.
Oh, I didn't realize I was unmuted.
You are. P is the only place that X is positive. Q, X is going to be negative. And S, X is going to be positive and Y is going to be negative. But can I use a cosine down here in this quadrant?
No.
No, cosine is only up here. So this is going to be cosine. This is going to be cosine, sine, and tangent. And this is only going to be sine and tangent.
So you could go ahead and do C because that means it's Q.
That is correct. C is Q. Look at you looking ahead. So Sadie's knocking out the two cosine functions. The negative is in Q, the positive is in P. Where is the sine a negative Y?
S.
S. And where's the tangent a negative Y over X? So one of them is positive and one is negative.
S.
Also S. Very good. Okay, here ends the notes. Now, you guys are going to have a conniption when you get to the homework because, like I said, I went out of order. So I'm going to jump you to these 4 problems right here on your homework. Do not panic if you don't understand. I did not teach this lesson today, but I think you can kind of struggle through it a little bit. These are the equations which come to lessons 10A and 10B. We're actually doing 2 days on lesson 10. Who can tell me where the inverse cosine is 0? At what angle is the inverse cosine 0? Now, this is the homework, guys. This is worksheet A. Should we go back? Actually, look.
Pi over 2.
Yeah, you're correct. Okay, so let me grab this, copy it, and go back here. Okay, so at pi over 2, the inverse cosine is 0. So I'm going to say the inverse cosine of 0 is pi over 2. And now what you have to find is where the inverse sine of x is pi over 2. So now here's, don't get excited. The sine of the inverse sine is a canceling thing. It's like squaring a square root or square rooting a squared. It cancels, right? So if I said, let's do this, let's say this, let's take the sine of both sides. The sine of the inverse sine of x, but remember I said of both sides, has to equal the sine of pi halves.
How can it be pi halves? Because I thought that was undefined.
The cosine is 0. The cosine is just the x value.
Oh, not the tan.
Not the tangent, right. The cosine is simply the x value. Okay, so remember what I said. The inverse sine and the sine are canceling functions. So I'm going to just say this cancels. And all I'm left with is x. So now what I'm saying is this. X has to equal the sine of pi halves. What is the sine of pi halves?
1.
1.
Right. Okay. So down here, you're going to first find this inverse sine of negative root 2 over 2, and that's going to be an angle. And then you're going to say the tangent of the inverse tangent of pi x. And won't the tangent of the inverse tangent cancel each other?
Yes.
Okay. So what is the inverse sine of negative root 2 over 2? Remember, the sine has to be in these 2 quadrants. So where is
Negative pi over 4.
negative pi over 4? So what I'm going to have here is the tangent, the inverse tan or the arctan of pi x equals negative pi quarters. And now remember, to get rid of this, I just say the tan of the inverse tan. So I'm taking the tangent of the arctangent or inverse tangent of pi x, but I have to do it on this side too. I have to say, well, then I need to take the tangent of negative pi quarters. Okay, remember this, the tangent of the inverse tangent cancels, so this side is just left with pi x. And now somebody tell me what the tangent of negative pi quarters is.
Is it -1?
It is indeed -1 because you're saying it's negative root 2 over 2 over positive root 2 over 2. So now I'm solving for x, so what do I have to do to both sides?
Divide by pi.
Exactly. -1 over pi is the answer to this one. Okay. Again, I'm giving you what we're going to do in Unit 10. Can you guys kind of struggle through these two? So you're going to first find this first, and that's going to be an angle. Then divide by 2. Okay, so you're going to divide your angle by 2, then take the sine of the inverse sine, 3. See what you can do with that. Sine of the inverse sine on both sides of whatever this angle is. Same here. First, second, and then third, you're going to take sine of the inverse sine. Okay, don't panic if you can't get that done. All right, what I want to do for the rest of the block, and I can see, oh, nobody started. Good.